Hello guys, welcome back to my channel. Mason African Motives are still working on engineering science N2. So in this platform actually we shall be focusing on the question which was written from the question paper of August 2021, where we are going to focus on mechanical drives and lifting machines. So in this platform we have a question that is actually chosen question number 5 that we have, and that is the first part of the question. As we can see, then the other part of the question, which is 5.4 continuation here, to give us a total of 17, as we can see. So that's how they can actually ask these questions. 17 marks, which is a lot of marks in exam. So actually, for you guys, you can consider being part of the family by subscribing so that you won't miss any of the classes that we shall be having. So on 5.1, which is actually there, which is working on gear drives, we are given a clock watch has 2 gear drives with gear A driving gear B. The following is known. So this is the information that we are given that is known for that for the 2 gear drives that we are given. The number of teeth, we are given the teeth A, which is 25 teeth, the number of teeth of B, which is 50 teeth, which is something that is common for these two, to say that we are given the number of teeth of gear A, which is 25 teeth, and for B, which is 50. But for A, we are only given the rotational frequency only. We are not given the rotational frequency for B, but we are given the number of teeth, which are for A and for B, so you can relate the two. Because remember, when you are working the gear drives, you are working with something like this. All right, then we shall have our A like B, A and B like that. So in this case, this is our A and this is our B. So we are talking about the driver, which is this one, which is driving gear B. So the relationship, as long these two are in a condition that one is driving another, then we can use the relationship of the number of teeth versus the rotational frequency, so that it can be an advantage. Because in this case, the question is calculate the rotational frequency of gear B, so we can use that relationship. Okay, so we're going to use NA TA is equal to NB TB. So we've got the rotational frequency, the number of teeth, the rotational frequency, the number of teeth. So what we need is to find the rotational frequency to the gear B. So which means we have to make this NB to be the subject. So you can divide by TB. You can divide by TB in this case. So that means the rotational frequency for the part which is the driven, because this is the driver, this is the driven, okay, it's going to be NA TA over TB. So you can make to transpose, make N to be the subject from your mathematics, guys. You can do this one much better. So you can just substitute now the values of NA, which is ones that we are given here. In A, that's 7. If you take note, these are in revs per minute, so which means your answer is going to be also in revs per minute. So we have got 750 multiplied by TA. Our TA is 25 and TB is 50. So it's 25 and TB, that's a 50 like this. All right. So that means I can simplify this at once using my calculator. You're going to obtain 375. Remember, the first one was a revs per minute, so definitely this one is going to be also in revs per minute. So this is going to be your NB, which is the rotational frequency that is on gear B. So that's how you actually take this relationship, guys. It's nothing much. Then the velocity ratio of the system. You know that the velocity ratio of the system can be given using the rotational frequency. It can also be calculated using the number of teeth. So we have got 2 options that we can use for that. All right. So what is going to be the formula now? what are we going to have in this case for the velocity ratio? Okay, using the number of teeth, which is TA and TB, you are going to use the driven over the driver, TB over TA, the driven over the driver, TB over TA, which is going to be TB, that's 50, over TA, which is 25. So you're going to have 50 over 25. All right, so dividing this, you're going to obtain 2 from a calculator. So therefore, that means our velocity ratio, because this is a ratio, so it's going to be 2:1. So your velocity ratio is going to be a ratio of 2:1. It's a ratio, this one, because when you write TB over TA, it means TB/TA. That is what it means. So that is why your final answer, you're supposed to write it in this format. So like I said, you can use the number of teeth or you can use the rotational frequency. When you use the rotational frequency, you're going to work with the driver over the driven. It's now opposite, driver over driven. All right, driver over the driven. So which means our velocity ratio was supposed to be also calculated by this driver over driven, which is NB. All right, so the driver, we're given a rotational frequency of 750 reps per minute, so it's going to be 750 on the driver. The driven is the one that we calculated previously. If you still remember, we obtained 375 from NB, the one that we calculated first. So it's going to be 2 again, which is therefore the velocity ratio will be 2:1. It's going to be 2:1. So this is what is important there, that the velocity ratio can be given as a ratio like that. As you can see, it's a velocity ratio. So you must remember that you are working with a ratio, so definitely your answer is going to be in that format. Okay, on 5.2, name 2 types of hoisting devices. Okay, and we've got 2 marks for that. Okay, so which of the hoisting devices are we talking about? So I just have 3 of them that we can choose the best answer from these ones that we are having from hoisting devices. We've got a differential wheel and axial lifting device. We've got a differential winch. We've got a Weston differential pulley. So these are the hoisting machines, that devices that you can actually use in favor. We just choose the ones which are best for you, but that is what we have there. All right, then we are now given that a differential wheel and axial device which is one of the ones that we talked about there, has a velocity ratio of 20. Okay, then we are given D1. So this one, it's best for you to list the information whenever you are working with a differential wheel. It's best for you to just take down your information. So the velocity ratio is 20, okay, which is just same as 20:1. Okay, then we are given D1 in millimeters, which is 300 millimeters. We can just leave it like that in millimeters, or you can convert to meters. So just gonna leave it and write both. Maybe it's gonna paste 0.3 meters here and 0.24 meters. All right, so then we've got, take note here guys, this is with a mass on effort of 6. Take note, this is the mass on effort, 60 kgs. So let's just write like this: mass on effort 60 kgs. Then the mass of the load 800 kgs. So this is the mass of the load. So just say L for the load, which is 800 kgs. So take note, this is for the effort, this is the mass for the effort, and this is the mass for the load. So take note guys, do not confuse this part. These are different masses that you're given, one for the other and the other one for the other again. Calculate each of the following now from that information that you're given: the mechanical advantage of the machine. what is going to be the mechanical advantage of the machine? You must understand this here. From your formula sheet, you are given that the mechanical advantage actually is load over effort. Load over effort. So which means if it is load over effort, remember, sorry, load and effort is all about mass times the gravitational acceleration. So that means this one is not going to make sense to actually multiply, but let's do it because of the formula, guys. Okay, just have to do it because of the formula. So this is 5.31. We want to calculate the mechanical advantage. All right, and we said the mechanical advantage from the formula that I showed you is load over effort, which means mass of load times the gravitational acceleration, mass of effort times the gravitational acceleration. But as you can see, we are multiplying the same thing. Okay, let me write it so that you can see. The load is mass times gravitational acceleration, but we're talking about the mass of the load, which is 800. We're talking about the mass of the effort, so it's going to be 800 times 9.8. Okay, all right, sorry for that. Let's just divide this by 60 by 9.8 again for the effort. But this part of multiplying by 9.8 here and also 9.8 here does not make sense, because you're just saving the same thing, which is the G. So you can actually leave this part. It does not even affect our question. Anyways, we can leave it like that, or you can just use it like that. So depending with the way that you decide, but you're going to obtain something like 13,33333, something like that. All right, so you can round off this to 3 decimal places. So as we can see, this one is going to be a constant. Why? Because you're working with the same units here. This was in newtons, this was in newtons, so they'll cancel each other. So that means we are going to obtain a constant value. There is no unit for mechanical advantage, so just going to leave it as a constant value like that. Now we've got the mechanical advantage. The question further on goes to ask us to calculate or to have the effort distance for 1 revolution of the drum, which is 1 rev. So 1 rev of the drum means a revolution. All right, what is going to be the effort distance? This is what I want you to understand, guys, from the velocity ratio. Let me show you here how it's given here. This is the velocity ratio here, which is actually the effort distance over the load distance. But we have got a lot that we are going to talk about here. A lot. Which part are we talking about? Which is a lot? Let me write it down. We've got a lot that we are supposed to talk about. We said the velocity ratio is going to give us this information from the formula that I just showed you now. It was velocity ratio is equal to effort distance over the load distance, like this. And as we want to calculate the effort distance, so which means what we are going to do is to simply make this to be the subject, the effort distance. So just cross multiply both semis of 1, so you can just cross multiply. So it's 1 times, we are going to have the effort distance, which is equal to the velocity ratio times the load distance. Okay, this load distance is given by a special formula, which is, let me write this formula for you. The formula for load distance is given by SL is equal to pi into D1 minus D2 over 2. This is going to be our SL. So as you can see, we are going to apply that part where we had D1 and D2. So someone was wondering, why are we not even using this D1 and D2 here? So that is where now we can apply our D1 and our D2. So The velocity ratio is already there. We are given that the velocity ratio in this case is 20 for this information. So we're just substituting. So that is what you're going to do in this case. So you're going to have, let me just write it as what is 20 multiplied by SL. So since I wrote this formula for you guys, I'm just going to substitute here from this formula here. So it's going to be pi here into, that's D1 minus D2. Okay, so now depending with the units that I'm using, if I use meters, it's fine, but I'm just going to use millimeters so that my answer is going to be also in millimeters. Okay, so it's D1 minus D2. So it's 300 minus 240. That's 300 minus 240, close that bracket, everything over 2. So you're going to divide this part where we are talking about the load distance. This over 2 is not affecting 20. 20 is from the velocity ratio. So if you are to simplify this, you can actually simplify everything at once. You're going to obtain something like 600 pi. You convert that to a decimal. If you convert that to a decimal, you're going to obtain 188.4,9555, yeah, something like that, 92, something like that. So we can round off at least, which is going to be comma. This is 5, take note. So this 5 is going to change this into 6. So it's going to be 956, which is in millimeters. Since these ones I just neglected them in millimeters like that, which means I'm going to have my effort distance from the formula of the velocity ratio, that it is the effort distance over the load distance, but the load distance is given by the formula. That's the formula for the load distance. So that is how they can actually ask these questions, where you are supposed to be very, very careful on how they ask these questions and how do you answer such typical questions. Okay, another question now was on the efficiency of the machine. So how are we going to calculate now the efficiency of the machine, because you're given 2 marks for that. All right, so let's just write something here. So the efficiency, we can also take it from the formula sheet. It's given also from your formula sheet. This span is given as the mechanical advantage over the velocity ratio. Mechanical advantage over the velocity ratio. So that is the efficiency here. Okay, so you can use efficiency, mechanical advantage over the velocity ratio times 100%. So that is what you're going to have. So whatever that you're going to have, you multiply it to 100%. So let's just substitute this and see. We are given, if you still remember, from the values that we calculated, our mechanical advantage was 13,333. So you're going to just substitute here. The velocity ratio was 20 times 100%. So you can use your calculator also, which is going to give us something like 66,665%. So that's how you can end up with the efficiency, guys. I hope this one was straightforward from the look of things there. Okay, on 5.4 we are now given that we are given the tension ratio of the tight side to the slack side of a belt is 5:1. The force in the slack side is 500 Newton. The driving pulley has a diameter of 300 millimeters and its rotational frequency is 50 revs per second. All right. Calculate each of the following. 5.41, the speed of the belt, the power transmitted. So in this case, we have got a lot of things that we can talk about here. We know that the speed actually is given by this formula. I'm not going to list down the information this time. I'm going to work with this information as it is. We can just use this information as it is. We have got the speed here. So actually we can use pi dn. We can use this for the velocity, guys. Pi times d times n. What are we talking about here? Which d are we talking about? We are going to use the diameter because this is the driving pulley is a diameter of, and it's so we have a condition where we are given the diameter at the same time as with the rotational frequency. If it was on the other, is provided that the information is from one of the sides, because we've given two sides, the driver and the driven. Okay, so in this case, and also this time there's no way we are supposed to use our distance, our diameter here, which is in meters, then the revs in revs per second. So we can actually substitute pi times the d, which is the diameter in meters, which is you're going to divide by 1000 on that 300, so it's going to be 0.3 multiply by n, which is 50. All right, so I can just use my calculator just as usual, guys, which means I'm going to obtain 47.12388, something like that. Okay, which is going to be 47,124. Normally I use my answers as 3 decimal places, guys, and this is velocity, which is measured in meters per second. So what you are supposed to do, guys, is to at least understand how to use the formula. How to use the formula is something which is best. The connection of the dots there is something which is very, very important. Okay, another part now is to calculate the power that is transmitted. How are we going to have the power? Okay, also from your formula sheet, the power is given. Let me show you guys, it's not as if it's not given here. All those things that we had, NA, TA, what were they given, all these. Okay, so here is your, this one is the one that we talked about now. V is equal to pi dn. So this is velocity. Then now power is effective tension times what? Times the velocity that we just calculated, which is the effective tension, that is the effective force in actual sense. Okay, so this is what our formula is going to look like. Power, that's the effective tension times the velocity. So this is item is this 5.42. all right, so where are we going to have this now? Because we do not have this one is there, but this one we do not have. So we're supposed to find that. Also, we are given the effective tension here, which is the effective force, as T1 minus T2. So if that's being the formula, which means we can calculate this, since we know that the effective is equal to T1 minus T2. But where are we going to have T1 and T2 now? All right. From the information that we are given the ratio here, the tension ratio of the tight side force to the slack side of a belt is 5:1, which means the tight side, which is our T1 over T2, is equal to 5. That's our velocity. That's our tension. That is the ratio of what? Of the tensions there. So we are also given this, that T1 over T2 is equal to tension ratio. T1 over T2 is equal to tension ratio, and your tension ratio is 5. And what are we given in this case? We are given the value of the slack. So we are given the slack side, which means we are given T2. Okay, remember T1 is the tight side and T2 is the slack side. So if T2 is equal to 500. That's 500 Newton there. What about T1? So which means we can calculate T1 from this because we are given the value of T2. So it's going to be T1 is equal to, you multiply both sides is 1. 1 times T1 is T1. T2 times 5 is going to be 5 T2 like this. So that means our T1 is going to be 5 times T2, which is 500. So we're going to multiply it 500, which is going to give us something like 2,500 in this case. So with this, now we can calculate the power now, because we now have the effective tension. The effective tension is there, which is 2,500. Then we can multiply to the velocity, which is the one that we just calculated now, which was 47 comma something. That was our velocity, okay, which is 40. Guys, we just calculated T1, not the effective. We want the effective, sorry for that. So the P there is going to be, we need the effective, which we say T1 minus T2. So this is our T1, guys, 2,500 minus T2, which is 500. All right, now it makes sense. Multiply by them. This is our velocity here, which was 47 comma 124. So we've got 47 comma 124. All right, so let's just do it stage by stage and see, so that we can use our calculator easier, or you can just use your calculator at once, or someone can simplify 2,500 minus 500, which is going to be 2,000 times 47 comma 124. Now it can be easier for someone to multiply, because you're just going to obtain an exact answer there, which is 942. This is going to be 94248. But this is power, guys, which is measured in watts. Or we can just write kilowatts if you want, or this can be power is equal to, which is divided by 1,000. So if you divide by 1,000, it's going to be 94,248. That will be in kilowatts now. So this will be in kilowatts. So that's how they can ask these questions. So as you can see, guys, working with mechanical drives, guys, and lifting machines is something that is supposed to be understood, that that's how they ask these questions, and you're supposed to work on more questions in order for you to actually know how to answer these questions. Because one thing is that they repeat these questions in a different manner. So the moment that you work with more questions, then it's now easier for you to attempt these questions, because that is the condition that you're going to have in most cases, and you're going to see these questions repeating themselves here and again. You work on this question, you work on another question, you are still having the same thing or the same application. So that's it, guys, for Mason African Motives, working on question papers and revision for for engineering science. This is engineering science, guys. This issue of working with maths, but here we are working with engineering science. And till we meet again.